Testing, one, two, three. Testing. Here today, we have a lot to talk about. First and foremost, I wanted to welcome everyone here who's taken some time out of their Tuesday afternoon to meet with us and talk a little bit about winter weather awareness and what this winter will bring to the region, and then some safety tips that we can all use as we go through the upcoming season. We'll have about an hour to more likely an hour and a half of talk here later today. We'll go through a whole bunch of topics. So a little bit about why we're doing this today. We're going to talk a little bit about that. We're going to talk a little bit about the historical winter perspectives and then how we're going to stay aware when winter storms or winter weather may threaten us. We're going to learn a little bit more about how we stay safe, both before, during, and then after that snowstorm or ice storm or cold weather moves through the region. We're going to learn a little bit about how to measure snow and how to measure ice that may fall. And then we're going to learn how to report those things back to the National Weather Service. And then in the end, we're going to wrap up and we're going to have some resources to share that you can all use and share amongst people you may know for the upcoming winter season. So a little bit about myself as we get started. My name is Matthew Dukes, and I'm a lead forecaster here at the National Weather Service office in Sioux Falls. I've been in this office now for almost 10 years, previously coming out from the National Weather Service office in Kansas City. I'm a resident or born and raised in the state of Wisconsin, so I like to think of myself as being a little bit more aware of winter and what the winter hazards can bring to us. Now, some administrative items, so to speak. A couple of times you're going to see a little QR code on your screen. By viewing those QR codes with your phone or camera that you might have, you're going to be taken directly to those pages that we're talking about here today. A couple other things. There's a link on your screen right now that's weather.gov/FSD/winter weather awareness 2024. I've thrown this into our chat here today, but going to that link will give you a lot of different resources that we're going to talk about. Some links to some various websites, some handouts for how to measure both snow and ice, and then also our NWS contact information is going to be on those pages as well. So a little bit more about the National Weather Service. If you don't know where we're at, we're located here up at the airport in the city of Sioux Falls. Have you ever driven by the airport in Sioux Falls and seen that big white ball in the skyline? Directly below that is our office. You can see our picture here from a few years ago when we had a fairly high wind and snowstorm move through, and it plastered the front of our building with a bunch of snow. Well, the National Weather Service is a team of about 25 meteorologists, administrative staff folks, and technological support staff to help keep the computers and everything in the background running. We're here 24/7, 365 days a year. We never shut down, no matter what the weather brings to us. One of those interesting facts you may or may not have known is we're one of 4 offices in the country, and the National Weather Service has 122 total offices that covers 4 states. So you can imagine sometimes the complexity of communicating weather information across all the partners across those 4 state areas. But we have a lot of jobs that we do here in the National Weather Service where we make a 7-day forecast. We also issue all of the warnings and advisories for the area. So winter storm warnings, winter storm watches, and in the springtime, severe thunderstorm warnings, severe tornado warnings. Any sort of watch or advisory is going to originate at our office here in Sioux Falls for our 45 county area. And speaking of that forecast area that we cover, we already talked about covering parts of 4 different states. Well, we cover an area here highlighted in gray in the map, anywhere from Huron to over on the east side in Marshall, Spencer, Storm Lake down in northwest Iowa, Sioux City, and then along the Missouri River, going up the river from Yankton to Vermilion, over to Gregory, and then up to Chamberlain. So quite an expansive area that, well, brings a whole lot of hazards and a whole lot of different weather scenarios to our area. Well, we're not just doing forecasts and warnings. We're also providing some specialized forecasts, both for rivers, hydrology, we like to call that, fire weather, aviation, and then various other sectors. We're also working hand in hand with many of our local partners, both in the schools and the emergency management field, to provide event support or any support that may come up with incidents in their communities. So that's just a little bit about the National Weather Service. So why is winter safety so important to us? Why do we do talks like this? It's not just to have fun, it's to learn. And it's to learn because weather impacts everyone. About 70% of the US population lives in an area that can see snowfall. 24% of weather related crashes are actually due to weather conditions. And it's expensive. State and local governments spend over $2.3 billion on winter weather operations every year. So the planning, the forecasts, and then those impacts are very, very impactful for our communities. And did you know that almost 1,300 people are killed every year and almost 117,000 people are injured in wintry road conditions? So that being said, we have to know a little bit about what winter is typically like in this part of the country. Well, the first thing we need to look at is snow. The map here I've included on the left side of your screen is going to show the average or normal snowfall that we tend to see across most of the region. And in the Dakotas, southwest Minnesota, northwest Iowa, and northeast Nebraska, typically ranges between 35 and 45 inches of snow. You can see some of those specific snowfall totals on the right side of your screen. Here in Sioux Falls, about 45 inches, but you go down towards Spencer on the east side, about 35 to 40 inches. And then along the Missouri River, it drops maybe a little bit further down into the mid to upper 30s. Well, when does that snowfall typically start? Well, this fall has been another slow start to the fall winter snow season. Now, some areas in southwest Minnesota and northwest Iowa have seen a little bit of snow at the very end of October, early November. But on average, most areas just haven't seen any snowfall yet this year. You can see our average snowfall is about that first to maybe second week of November. Now, we aren't going to experience the earliest snowfall on record, and we probably aren't going to experience the latest snowfall on record. You see some of those dates. We've had some of those latest first snows, first measurable snows, as late as Christmas time or even the very new part of the new year. But the one thing, if you lived here long enough, you're going to know that it can snow a lot of the winter season. We're currently looking at a map right here or a chart that shows the distribution or the frequency of 1 inch or greater snowfalls. As you can generally see, and I'm going to turn on my laser pointer here, we're about into the early portions of November. Our snow season can begin as early as late September or early part of October, but we just don't see snow that often in those time periods. When we begin to see that snow accumulation or that potential for snow begin to increase, well, it becomes late November, especially December, and then on through the winter months. The one thing I want you to point out here is that even though the fall and the early winter seasons, parts of the winter season are slower than normal, we see a secondary surge in the frequency of snowfall. Usually begins late January through February and then continues into early March. And why is this? Well, it's that changing of the seasons that begins to take place. We get a little bit more warmer air into the region. We get a little bit more colder air kind of clashing at times with those different air masses. And well, our snowstorms can typically be a little bit bigger. More snowfall, more rainfall, more mixed precipitation in those early spring or late winter snowstorms. So the overall takeaway here, it can be a long winter. It can start snowing in October, and as the frequencies and the distribution shows us, we can see snow all the way through April and even early May. But what's winter cold like? We know what the snow is like, but what about the cold? Well, did you know that most areas here average about 55 to 65 days with a high temperature below freezing? That's just your average temperature. Now let's look at those days when we have that more dangerous cold. Wind chills of minus 20 or colder are when we begin to see typical impacts from cold exposure in this part of the country. And on average, most places see 14 to as many as 28 days, depending on how the winter pattern sets up for those wind chills that begin to lead to more concerns. But how about that extreme cold? That cold that can be life-threatening and can cause frostbite or hypothermia in short amounts of time. Well, when we start to look at wind chills 35 degrees below zero or colder, most places were only averaging about 1 to 3 days winter season. As you move north, obviously, you have a better chance. Northern South Dakota, 3 to 7 days, and then most of northern Minnesota and North Dakota, as much as a week to even 2 weeks, where temperatures may briefly reach that minus 35-degree mark. So we talked about snow, we talked about cold. How do we get all of these things? What kind of air masses do we deal with in a winter season? Well, most of our air masses resonate from central and southern Canada. We call that a continental polar air mass. When we get those extreme cold Arctic air outbreaks, that's that deep Arctic cold, continental Arctic air mass that's going to cross and bring most times below zero temperatures into the area. But how do we get that moisture for snowstorms? Well, we're looking at two different areas: the Eastern Pacific, otherwise called the Maritime Polar Region, and then the Maritime Tropical, which is usually the Gulf of Mexico. Anytime we can start to tap in some of the air masses in those areas, the moisture in the air increases and we tend to see a little bit more precipitation when storm systems move through the area. But where do those storm systems originate from? Well, we tend to see three different storm tracks across the region. The first and the most common is what we call clipper systems. They're systems that originate in Western Canada, zip down to the southeast across southern Canada, cross into the Great Lakes, and then move off into the northeastern United States. These northwest to southeast moving storm systems tend to do a few things. They move so quickly that their snowfall amounts are usually fairly light in nature, but they can bring fairly strong winds on the backside when they move through, and they can bring those quick shots of air from Canada that may quickly drop your temperatures after the precipitation ends. You may hear some of these terms like Alberta clippers or Saskatchewan streamers or Manitoba maulers. These are just other names that these clipper systems have been known for. Now, the most potent snowstorms or snow systems, one very similar to what we just experienced across the last week, is something called a panhandle hook or a Colorado low. These are less frequent. They are typically storms that are going to pose the highest potential for bringing high precipitation amounts. The storm system we just had move through the area here over the last 24 to 48 hours was able to tap into some of that Gulf air. And well, what did it result in? Nearly record precipitation in many communities across the area. Now, these panhandle hooks originate from the eastern Pacific. They tend to dip down into the southwest United States and then take a quick northeast trajectory into the northern plains and Great Lakes. Because they tap into that Gulf moisture, you have higher precipitation amounts. And when it gets cold enough, and when storms like what we saw are able to produce their own cold air, which they can actually do, you can tend to get that rain changing over to snow at times. Now, when they wrap through the area, they're also going to be able to do something like what we're seeing here over the next 24 to 48 hours. They can hang around and they can pull colder, and sometimes they can bring colder air and snow showers or even light snow into the region. The last storm system we're going to talk about is something called a progressive zonal flow low. So these storms originate from the eastern Pacific. They tend to track almost due west to due east, but they're going to bring some of that eastern Pacific moisture over to them. They move fairly quickly because a lot of times they have a little bit of a jet stream interaction with them. And they can tap into some moisture, tap into a little bit more warm air, and they tend to lead to a little bit of mixed precipitation on their onset. Now, if they can't always warm up fast enough, a lot of that precipitation is going to end up as snow. So these fast moving storms could produce a quick dump of a few inches or even 6 or 8 inches of snow as they move through the region. But what determines what falls from the sky? Well, it seems fairly straightforward, but it's actually the temperatures above the ground that determine this. We all know that we can get snow, sleet, freezing rain, and rain. But when we look at how these different winter precipitation types are created, we have to look at those atmospheric temperatures. Now, in the case of rain, as you can see here in the example, snow falls from the clouds, and all of the temperatures down from below that cloud layer to the ground are all above freezing. So all of that snow melts and hits the ground as rain. But as you get a little bit colder, say that warm layer of air is a little bit more narrow and the ground is a little bit colder. Maybe it's below freezing at the surface. So that snow falls from the clouds, melts into a liquid, and then falls into a new freezing or shallow freezing layer near the surface. And a lot of times when it hits those cold sub-freezing surfaces, that's when you get rapid ice accumulation. Sleet is a little bit of a different situation. Snow falls from the clouds, hits a more narrow warm layer, only partially melts, kind of turns into snow-coated water. Well, that falls down further into the atmosphere into a more deeper cold layer near the surface. And what that does is it turns into little ice pellets as it reaches the ground. And the most simple one is snow. All the temperatures above the ground level are below freezing, so anything that falls from the clouds falls all the way to the ground as snowflakes. It never melts. So as meteorologists, we're looking at one unique variable, and that's something called the temperatures. So we have an atmospheric sounding here. I can zoom in real quick. This is what we're going to look at. This is a sounding that goes vertical. So we're sampling all of the temperatures up, higher up into the atmosphere. So we talked about snow falling from the clouds. So it's going to fall from the clouds until it hits a layer that's above 0 Celsius or 32 degrees Fahrenheit. This very narrow warm layer melts all that snowfall into liquid, which then falls below freezing or into a layer of air above the ground that's below freezing. So this is a pretty classic freezing rain sounding that we're going to see at times throughout the winter season. It's just one of the things meteorologists look at to help determine the weather in the area. But not all snow is the same snow. We've all experienced this. We get wet, slushy, very hard to move snow, and then we get very fluffy snow that you can almost blow with a leaf blower. How do we determine this? Well, it's something called the snow liquid ratio. And what's the snow liquid ratio? It's a fancy term for basically calculate the calculation of how much snow can be produced by 1 inch of liquid. So in this part of the country, our typical average snow liquid ratio is about 13 inches of snow to 1 inch of liquid. But when you talk about really heavy and wet snow, you might have a snow liquid ratio only about 5 inches to every inch of precipitation. Or in the case when it's really cold outside, when the temperature falls almost to zero, you might start seeing snow liquid ratios as high as 15 or even 20 to 1. So that means any liquid that falls from the sky has a much higher probability or higher chance to turn into more snowfall accumulation. And one of the neat things about weather in this part of the country, because we're often kind of the battleground between warm air masses from the south and cold air masses coming in from the northwest, we often get something called thunder snow. Well, what's thunder snow? It happens when you get a clash of those air masses. Sometimes that warm air mass is so strong it surges over top of the cold air moving southward. That can create a turbulence in the atmosphere, an overturning, and that in turn creates a static charge in the cloud. Sometimes that cloud gets released, and what do you get? You get a big flash of lightning and you get a big rumble of thunder even when it's snowing. Why is that important? Well, just like we see in summertime when we have a thunderstorm go through the area, thunderstorms are just another form of turbulence, stronger energy, and what do? They produce high rainfall amounts. So in the wintertime, it's the same thing. When we hear thunder, we see lightning and snow, it creates a much more unstable environment or indicates a more unstable environment, and you can get snowfall rates as high as 2 to 4 inches per hour. So let's talk a little bit about this upcoming winter season. What's going to drive our winter patterns this year? You may or may not have heard something called the El Nino Southern Oscillation, or ENSO. Well, all that is a fancy way of saying, what are the temperatures down near the equatorial Pacific? Are they colder than normal, or are they warmer than normal? Are those sea surface temperatures warmer or colder? Well, when we talk about things like La Nina, which is what we're going to learn about in just a second, we're starting to learn that the temperatures at the equatorial Pacific are a little bit colder than normal. There has been an upwelling in the ocean circulation, causing those colder temperatures to rise. However, in the opposite side, in El Nino, those Pacific temperatures over the ocean are a little bit warmer. Why does this matter? Well, the influence of these temperatures has a direct influence on where the location of the jet stream is going to take place over the Pacific and then over the northern United States or North American continent. This influences both our temperature and our precipitation patterns across the country. So this year, if you haven't heard, is what we would consider a very weak La Nina year, meaning we see some signs of those cooler temperatures near the Pacific, but they're not very strong, or those temperatures aren't extremely cold. This is the map I'm showing here is a typical impact from what we would consider a La Nina year. That jet stream shifts a little bit further north, more towards Alaska and the western Canadian coastline. What does this do? It has a tendency to pull more colder air down into the midsection of the country and into the Great Lakes. It also tends to focus on the moisture a little bit differently. The Pacific Northwest tends to see a few more atmospheric rivers, tends to see a few more higher end rainfall events, and that same effect can end up impacting the Rockies in the mountains. It can be typically higher snowfall in those areas. The other place we tend to see more precipitation into the Great Lakes and Ohio River valleys. But this is just one of those global circulations we're looking at. We've got a few others we monitor that you may or may not hear of. The Arctic Oscillation, the North Atlantic Oscillation, the Pacific North American Pattern, and the Antarctic Oscillation. So what does this winter season look like? Well, here's the outlook released by NOAA here back in mid-October for the winter season, the typical meteorological winter season, December, January, and February. Right now, we're seeing at least a slight preference or slight favor towards below normal temperatures throughout most of the northern United States and Pacific Northwest. You got to remember that La Nina pattern takes that jet stream and has a better chance of pulling colder air southward into the northern United States. As far as precipitation goes, it's a little bit more uncertain. For the Great Lakes, Ohio River Valley, and the Pacific Northwest and mountain regions, it's just what we talked about, a tendency to see at least above normal precipitation. Locally, though, we have what we call equal chances. Now, this doesn't mean that it's going to be a normal winter. That just means that there are no strong signals pointing to above or below precipitation levels. But some NOAA scientists over the last few months have taken a look at maybe breaking down, knowing that we're going into a La Nina winter, what we might see. The map on the left here is a snowfall plot of the difference from average snowfall during all La Nina winters through the January and March seasons. So this is kind of the dead of winter through early spring. In the tendency, what we see in all La Nina winters is maybe a tendency towards slightly normal to maybe even slightly above normal precipitation. That doesn't last very long. Once you get south of, say, the Missouri River and then across portions of Iowa, Nebraska, Missouri, you have a tendency to see a little bit less snow than normal. But remember, this is a very weak La Nina or almost a neutral phase. And the calculations on that data, looking at that same time frame, show kind of what we've seen. There can be a tendency, at least during the middle to end or second half of winter, to have a favor towards above normal snowfall in the region. That may not mean we're going to see 60 or 70 inches of snow, but that may mean we have a little bit slight preference towards normal to maybe slightly above normal snowfall. Have you ever heard of something called the polar vortex? Well, this isn't anything new, but it has become a more used term over the last 5 to 10 years. Now, the polar vortex is always around. It never goes away. It just strengthens and weakens. And what it is basically an area of low pressure along the poles that tends to trap colder air near the poles most of the times. When the jet stream is very strong and unidirectional, that is what we call a stable polar vortex, meaning that colder air can basically stay in place all winter season. But we know that's never the case. We get storm systems when the jet stream tends to shift, and we get troughs and ridges of the jet stream moving through the northern hemisphere. Sometimes when that happens, we get little pieces of the polar vortex that may split off and may kind of move towards the lower 48. All this means when you start hearing this term of the polar vortex returning, it just means it's not a new storm. It's just an expansion of colder air that was kind of stuck or trapped up into the Arctic that kind of sinks down with a jet stream and will likely produce at least uh, a brief or an extended period of below normal temperatures. So what should we plan for this winter season? We've talked about the snow, we've talked about the cold, we've talked about the general winter outlook. Well, we crunched some numbers here locally and kind of determined how many of these typical headlines that we see per winter season. And this is just based on the last 15 years. Now, winter storm watches is kind of that heads up that maybe an impactful winter storm may be heading towards our area. On average, we see about 3 to 4 of these per winter season. Blizzard warnings, those are our highest end products. When life is certainly threatened, we don't want anyone traveling on the roads. Visibility is near zero for a longer duration. The good news is we tend to see fewer of these, only about 1 to 2 on an average season. Winter storm warnings, this is again when we're going to see heavier snowfall, maybe a mixture of freezing rain, snow, and strong winds that is expected to or could potentially lead to some significant impacts. Again, the good news is we tend to see only about 2 to 4 per year. Winter weather advisories, those are a little bit what we consider more nuisance winter events. It's not going to directly impact your life, but it may produce some delays on the roads. It may cause you to have to change your plans slightly. Not high-end snowfall, not high-end icing, not high-end visibility drops. We tend to see more of these because we have a lot of nuisance winter storms or snowstorms throughout the winter season. 10 to 15 is what we calculated per winter season. In ice storms, thankfully, this is when we see ice accumulations over 1/4 of an inch and that kind of destructive ice that brings down trees and power lines. Thankfully, on average, we only see these less than 1 per year. A lot of winters, we may not even issue some of these headlines. So how do we stay aware of the winter weather coming to our areas? How do we stay aware generally of what's approaching us? Well, we create several products. One of these is called a hazardous weather outlook. Now, if you head over to our webpage, and we're going to show you a few of those resources in just a minute, and you click on the map on the headlines or on the map in the center of the page, you're going to see something called a hazardous weather outlook. This is a generalized outlook that will talk about the forecast over the next 7 days. It's meant to kind of be a tap on the shoulder to kind of say, here's what we're expecting right now as far as weather. Here's what the potential is over the next 7 days. Is there a chance for snow in 2 or 3 days? Is there a chance for very cold temperatures over the next 5 to 6 days? Those are the kind of things that you might see in a hazardous weather outlook. But we've already talked about, we have other ways of staying aware. Watches, advisories, and warnings. When you hear the term watch during winter season, it means we want you to be ready. It means there's a growing potential, likely more than 50% chance that we're going to see impactful winter weather that's going to disrupt your lives. Doesn't mean you need to take action right that second, but it's time to start paying attention. It's time to start preparing for the potential of weather impacts in your area. When you hear the term advisory or warning, these are issued when winter weather is expected to impact your area. Remember, advisory is still a significant event. It just doesn't mean that it may not be life-threatening to everyone. We're expecting minor disruptions of travel. There may be slower roads. There may be some cancellations, but not everything. We want you to use caution if you head out in these events. Warnings. These are the most higher end terms that we tend to use. When you hear warning issued, much like a severe thunderstorm warning or a tornado warning, we want you to take action. It means that weather is threatening us either in a little bit or actively. It means you're going to have major disruptions to regional travel, regional impacts. Your life is going to likely be impacted in some way by delays or cancellations or road closures. So how do we keep up with that forecast? Well, we talked about going to our website. Here is our website, www.weather.gov/Sioux Falls. This will take you directly to our National Weather Service office page here in Sioux Falls. There's a few different areas I wanted to point out on this page for you. Number one, there's going to be an entry spot on the left-hand side of our page where you can put in your zip code. That's going to give you, when you do that, it's going to give you the local conditions, at least your current temperature and sky cover. And it's also going to give you a brief forecast for today and tonight. But number two and three are probably some of the more important ones. If you click in on this map, you're going to see a listing of what the hazards are, and you're going to see a listing of your 7-day forecast. As you can see in the example I've shown here, we had an advisory in effect for the region. If you click on that map, you're going to be able to see more details about that winter weather advisory. Number four here at the top, anytime we have a major winter storm or any winter weather coming to the area, we make sure that we have a page called our winter weather resources page linked on it. We're going to talk a little bit more about what's on that page in just a second, but it's a great page that you want to bookmark for future reference. Number five here down on the left is something called a weather story. Now, every weather service office here in the north central United States creates daily weather graphics, kind of summarizing graphics of what we expect the weather to be over the next 5 to 7 days, but also when bigger storms approach the area or hazardous winds or snow or rain. We're going to go into a little bit more detail in some of these graphics that we post there. You're going to also see some of these same graphics in our social media feeds. Now, number six here is a radar. You can click on our radar link here to get the local Sioux Falls radar. You can also get to the national radar from this page as well. And number seven here is a product that we create more specifically to go into further details about weather that's coming into our area. If you head over to our page here today, we're going to talk about what's coming up over the next 48 hours, continuation of strong winds, potential for snowfall across the area here on Wednesday, and then the incoming colder air. These are what we call DSS packets or decision support packets. They're more detailed information that's going to give you a better idea of what to expect and potentially make your decisions based on the information that you're seeing. Now, we talked about that winter weather resource page, and you can see here the arrow where that's going to be located. If you click on our web page here today, you're going to see that linked up there as well. This is what we consider a one-stop shop for all those winter weather resources. You're going to get a listing of what current headlines, advisories, warnings, watches are in effect. You're going to be able to access our current snowfall projections or icing projections. You're going to see a listing to get the latest storm reports of what's actually fallen and what we've been able to collect and send out. There's going to be a page here called the Winter Storm Severity Index, which we'll talk about in just a second. We're also going to have a few different neat features on the bottom half of the page. 6 hourly graphics showing where snowfall is accumulating and how quickly it accumulates. Sustained wind speeds, sustained wind gusts, and then the wind chill values. So you can see the values across the region every 6 hours for the upcoming days. At the bottom of the page, if you're looking for a more specific hour-by-hour forecast, we've got hour-by-hour forecasts for multiple larger cities in the community. And these will go into a much more in-depth look at when the precipitation chances increase, when the snow or rain accumulation is going to happen, and then what the wind impacts are going to be. And one last page here, I'm going to flip back real quickly. There's a link here in the middle called Probabilistic Snowfall Page. Now, this is going to be more for the advanced users and maybe those that are making decisions. Over the last 5 or so years, the National Weather Service has really began to adopt and model their forecasts in a way of looking at all the potentials. So what we're going to do is we're going to take our forecast and we're going to begin to input that into various other models, as many as 60 or more. We're going to start making calculations and statistics to kind of get not just a certain exact precipitation amount, but we're going to be able to calculate what's the full potential that a winter storm may bring. So when I say this, you're going to see a few various different types of information. You're going to see something like, what's the percent chance of 2 inches of snow or more? Maybe you're a decision maker that needs to know what the threshold is or what the probability is for receiving 2 inches of snow. You're going to be able to get that information. How about something called box and whisker plots? That's a little bit more of a statistical kind of term, but what that's going to tell you is the overall range. It's going to allow you to see what the range is potentially at the lower end of this snowstorm, and what the potential is at the higher end of the snowstorm. And then, as you can see in the examples here, anything in the blue bar area here is where that typical snowfall is going to end up resulting in. Now, if you're a decision maker, we're also creating plots for various cities. So a chart here, if you're a decision maker in Minnehaha County or Moody County or Woodbury County, you can click on these charts and see what the low end snowfall forecast is, what we're expecting to fall in the area, and then what that highest potential is, what the least likely snowfall is going to be. That winter storm severity index was another link on that winter weather resources page. It's not necessarily new, but it continues to evolve winter season by winter season. What this does is it takes that National Weather Service forecast, it takes that snowfall forecast, wind forecast, a temperature forecast, and it puts it into a form of allowing us to depict what the impacts might be from that. It's going to look at a few different things like, is that impact going to be greater or less in a city? Is your area covered by more trees or more wide open spaces, which may allow more blowing snow potential? It's going to look at things like your infrastructure as far as power lines or trees for icing. If areas have higher tree loads or higher forest areas, your icing potential or impact from ice may be higher. It's a little bit more sophisticated than a snowfall forecast because it can look at individual elements and what their potential impacts to your area may be. We also have something that's really cool here. We do a lot of social media content. Whether you're on Facebook or whether you're on X, which was Twitter, you're going to see a various array of different types of information that we send out. Now, we typically send out information as soon as our confidence locally is high enough to begin feel like we need to begin messaging that. You may see certain kinds of plots such as this, the probability of seeing impactful snowfall, 5, 6, or 7 days out. You may see such things as the potential for snowfall. That might be low or medium or high of various thresholds, whether that be 2 inches or 6 inches of snowfall. And as our confidence grows, you're going to start to see our messaging evolve as well. We start to turn into more deterministic snowfall. So, well, how much snow are you going to see? When's that snowfall going to begin? We can begin narrowing down the forecast as our confidence and as model confidence also increases. And then again, as you get to the snow actually falling or the precipitation actually reaching the area, if you follow our social media feeds, you're going to see such things as the current road conditions, live conditions out into various portions of the region, and then those radar updates that can give you at least a projection as far as what your day might bring to you. So I really encourage you, if you don't follow us on social media, it's where you're going to see even more information from what you may see in our packets or on our websites. So speaking of those thresholds for headlines, here's a quick look at what we tend to look at. For winter storm warnings, again, we're looking at snowfall in this part of the country at around 6 inches or greater. Once we start seeing those snowfall accumulations, we start really considering the fact that this is going to produce a more significant impact. Now, that might be a combination of a few things. It might be 6 inches of snow with snow or sleet or freezing rain, or maybe higher winds causing more extreme visibility drops. The one thing to note here is that there's a 24-hour accumulation window for this snowfall. But I will put a little bit of a caveat on that. We're not going to likely issue a winter storm warning if we're seeing a 1/4 inch of snow or a 1/2 inch of snow spread out over 24 hours. That might be more of a winter weather advisory situation, since the impact or the potential to be able to recover from that is much more able to be done. Now, blizzard warnings, again, that's kind of our flagship winter weather product. It's one of the highest winter products we can issue. But a lot of people don't realize that even though we might see very brief periods of whiteout visibility or the roads may be significantly impacted for very, very brief times, that may not always necessitate a blizzard warning. We like to see blizzard warnings be issued when we tend to see frequent gusts over 35 miles an hour, so very, very strong winds. And we tend to see visibilities drop less than a 1/4 mile. Well, that can happen. Like it's just said, it can happen briefly in any winter weather event that moves through. So we want to put a time duration. How long is that going to last? So we typically like to issue blizzard warnings when we begin to see those conditions last for 3 or more hours. Now, ice storm warnings, thankfully, we don't have to issue too many of them or haven't issued too many of them recently, but they can definitely happen and it's something to be aware of. Anytime we start seeing a quarter inch of ice or more, we begin to see more impacts on both the trees, the power lines, and other surfaces. When you start to throw wind into that situation, it makes things even more difficult. A half an inch of ice with a 30 or 40-mile-an-hour wind can do quite a bit of damage when it comes to freezing rain and ice accumulations. Winter weather advisories, again, this is our most common or most likely product to be issued. This is for those times when we start to see snowfall, maybe 2 to 3 to 4 to 5 inches. Not at that 6 inch threshold yet, but those advisories can also be issued for a multitude of different combinations. Maybe it's an inch of snow, but less than a quarter inch of freezing rain. Or maybe it's a little bit of sleet, a little bit of snow, and a little bit of strong winds. We also will typically issue winter weather advisories in the case where we may have snow on the ground. Maybe it's been a really rough winter and we're tending to see a continuation of blowing snow or drifting snow that can lead to maybe some road impacts or some briefly reduced visibilities. You might see winter weather advisories be issued in those cases. Now we have had one winter weather related product change here for this upcoming winter weather season. And that's a simple change to some of the criteria and the wording for our cold weather products. Now in the past, we've had such things as wind chill watches, extreme cold watches, wind chill warnings, wind chill advisories. Well, some of our NOAA researchers really and social science researchers really looked at these things and they wanted to better match up what our criteria is for issuing these products across the country and then relate that to our actual impacts that we see. The other thing here, we need to recognize that cold is cold. No matter if it's the wind chill producing a wind chill of minus 25 degrees or just no wind and an air temperature of minus 25 degrees, the impacts are going to be the same. So we took some of this into consideration and renamed these a little bit simpler. So now we'll just have an extreme cold watch, an extreme cold warning for those very dangerous cold situations, and something called a cold weather advisory. We found that some of these terms are better related to create better action from members of the public. The good news is again, we want to talk about frequency. Cold weather advisories, the old wind chill advisories, were only issued about 6 to 8 times per winter season. And those extreme cold warnings, 1 to 2 times per winter year. Again, just a reminder, cold weather advisories, anytime we have a wind chill or an air temperature, minus 25 to minus 35 degrees. Again, this is when we start to see those impacts. Frostbite times, 15 to 30 minutes to any exposed surface. And they're, again, fairly common. Those extreme cold warnings are going to be fairly rare, 1 to 2 times, but it's those dangerous wind chills or air temperatures, minus 35 degrees. That's when frostbite times are 10 minutes or less. As you can see here from the map, here's a look at what the criteria changed. Really, the biggest change for portions of Minnesota and South Dakota is that looking through research and looking through impacts, there was some determination that that we needed to modify those numbers slightly. However, for the Sioux Falls forecast area, remember our 45 counties, we generally are not seeing any change in our criteria. The only area we're seeing a little bit of difference now is down along Highway 20, where there's just a 5-degree difference in those thresholds. Again, I just want to stress that we are still factoring in wind chill, and we're also now factoring in something called apparent temperature, which is just the combination of air temperature or wind chill. One last thing I wanted to talk about, we don't see a lot of these warnings in our area, but it's something called the snow squall warning. Now these are what we call short fuse products. Much like a severe thunderstorm warning or a tornado warning, they're issued for very small geographic areas. They're going to be issued for short amounts of time, maybe 30 minutes, maybe 60 minutes. And on radar, they're going to look a lot like maybe a brief thunderstorm moving through, small clusters or small bands of heavy or extremely heavy snow that's going to reduce your visibility significantly. Now, the one thing here is if we're in an active winter storm or active blizzard warnings ongoing, we're not going to likely issue some of these products. These are really meant to advertise the sudden onset, the kinds that may lead to pileups on the roads or mass impacts over smaller areas. The one thing we'll notice here is that they do tone alert, much like a tornado warning on your cell phone. If you're in an area that receives a snow squall warning, your cell phone is likely going to provide one of those somewhat loud and maybe annoying sounds. It's going to alert you to what's happening. Why is this kind of important? Well, we see the most impacts from snow squalls by people driving on the roads or driving on the interstates. And if we're able to give some sort of heads up as they're driving through their cell phones, through their mobile devices, that gives them enough time to find some way of avoiding what they're driving into. Now, if you don't get that alert, or maybe you run into an intense snow squall or snow band on the roads, what do we want you to do? We want you to try to find as safely as you can a way of getting off the road or pulling off far enough to avoid any further incidents until that band of snow or that significantly reduced visibility passes. Just like common driving practices, we want you to do the same things. Reduce your speed and increase your following distances as much as possible. Now, the one thing I want to talk about here is how you're going to get your information. We've seen this a lot over the last few years. This is an increase in the amount of outlooks, snow models, snow graphics posted 5, 10, 15 days out showing massive snowstorms that there's usually a very low probability of actually taking place. We want you to be very careful when you see these things and try not to follow what we would consider hype storms or hype snowfall storm forecasting. If you see some of those things, verify your source. Are they distinguished? Are they noteworthy? Do you feel you can trust them? And if you don't know or you're not sure, it's okay to ask somebody like the National Weather Service. Avoid clickbait. You're going to see a lot of people that may use buzzwords or catchwords to kind of grab your attention and make you want to say like this is a major thing, that it's going to be a dire situation. You must share it. You must retweet it. Again, we want you to verify that source and know if they're trustworthy or not. Be wary of rumor control. Be wary of those exaggerated forecasts. Know that the forecast you see past 7 days or 10 days is likely going to change. It's not going to be what's happening. Check the dates on graphics. We know the algorithms on social media change quite frequently. You know that you might not see a piece of information on Facebook, for example, for a day or two out from past when it was posted. So again, we want you to maintain situational awareness. You start to see those things, don't get too excited. Don't get overly excited. But maybe it's a time to check your forecast. Maybe you start to see, you're looking at the app on your phone and it's showing snow in 7 to 10 days from now. Keep it on the back of your mind, but don't bank on it. Don't count on it. Search for more information. Try to find more confirmation of it. How are we going to do that? We're going to follow those reliable sources. Our local media outlets are great at providing you the most updated information with those caveats in place. NOAA, National Weather Service, national media outlets, and various apps that are able to alert you. So let's talk about staying safe. Now that the storm is on its way, we're going to talk about how you prepare for it. 24 to 48 hours in advance of that winter storm, we still have plenty of time. We're in that outlook phase. You start hearing about those winter storms coming. The National Weather Service is starting to post about it. Your local media is starting to talk about a big snow in a day or two or a few days from now. This is the time to start preparing. Review your winter safety plans. Do you know who you're going to do you know if you need to make changes to your routine? Do you know if you have activities, before school, after school, at work? Might you have to make some adjustments? Get your home and your vehicles ready. We're going to talk about some of the things you want to put into a winter storm survival kit, both in your home and in your car. Check to see with your family if they're aware of it. Maybe they need some help around the house getting their stuff prepared. 12 to 24 hours in advance. A lot of times this is when you may still be under a winter storm watch or blizzard watch. Maybe advisories or warnings have been issued. We want you to make those final preparations. Make sure that you're charging your cell phones or have a spare power battery pack in your house in case you do lose power. We want you to follow your local media more closely or the National Weather Service because what have we learned about the weather? It changes quickly often. You know, we get a lot of model runs, we get a lot of model data that can simulate what's going to happen in the weather world. And we're going to see changes in that data nearly every time a model is run. So continue to follow that forecast and look for updates. Finalize those alternative plans if you need to. If you need to make changes to your life plans, appointments, meetings, that's the time to take those actions. And lastly, pick up those last minute supplies. Maybe you need a few groceries, maybe you need your medicines, those things. Again, we don't urge panic. We don't urge people to run to the stores and clear off the shelves, but we want you to be prepared. Typically, a big winter storm around here, you might need a day or two's worth of supplies. Most times we're able to recover fast enough. Now, unless it's the case of a major ice storm or major impacts like those, you might have to plan for a couple more days. And then under that 12-hour period, that snow might begin to fall. Maybe it's within a few hours. Put that safety plan into action. If you need to travel, let somebody know where you're going. If the snow starts falling, the easiest thing to do is avoid travel. We're going to talk about why that is in just a bit. And again, the overarching theme of all of this, continue to monitor the forecast. The forecast you see 2 days ago is not going to be the same forecast you see today. So in your home, what are some things we want you to do? Obviously, if you need medications or you have to get medications, check on them. Don't wait until the last second and realize you need a refill. Have a few supplies, in your house. Maybe you need a little bit extra for a day or two in case travel is limited. If it's a busy winter season and we have a lot of snow outside already, and we're expecting more snow, heavy snow and wind, make sure those furnace vents aren't blocked. Make sure that if your furnace is running, that air that it produces, those dangerous fumes, have a place to go. Check your shovels for your house, your driveway. Make sure your snow blowers work and don't wait until the last second to go get gas for those kind of things. Make sure your family is aware. Obviously, if you have kids or teenagers that have plans, maybe aren't, great drivers, make sure that they're aware of what is coming up. Go over some of the things that they might have to experience. Some of those things that you might want to grab, we already talked about making sure your shovel's good. Make sure you have salt, things like flashlights and batteries in case the power is out for an extended period of time. Bottled water in case we lose water in some communities. Blankets and warm clothing, most of us should have these kind of things in your home. Just make sure that they're more accessible. And again, we've talked about the importance of having a charged cell phone and charged battery pack. These are all some of the same things you're going to apply to your vehicle. You have to kind of look in the mirror sometimes and ask yourself, how prepared are you? How prepared is your home? How prepared is your car? Do you have those things in your vehicle that you might need if you get stuck in a winter storm? Have a safety kit, an emergency kit. And what are some of those things? Throw an extra blanket into your backseat of your car, in your trunk. Throw a bag of sand for a little bit more traction if you have a rear-wheel drive vehicle. Have a flashlight in case you get stuck in the dark and need to signal for help. Water and snacks is always good. I don't know how many of us have already put in your ice scraper or your snow brush since we haven't had any winter this fall season yet. One of those things, those typical vehicle maintenance things, make sure you check your fluids, windshield wiper fluids, test those wiper blades, make sure there's no cracks in them, that they're not going to prohibit you from being able to see when precipitation is falling. Ahead of snow or ahead of a heavier snowstorm, it's okay to make sure you have enough gas in your vehicle. If you get stuck in the side of the road and you're not sure when you're going to be rescued, you might need that gas. Place a shovel, scraper in your vehicle, and then always, 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 we're going to kind of harp on this again, always monitor your forecast if you're traveling, and remember that forecast changes. For those with work or school plans, we always encourage, both employers and employees to make sure you know your school safety plan or your work safety plan. What are your policies for school delays or for snow delays in the workforce? Encourage your employees to find where there may be more information, where you might have those resources in a handbook or on a web page. And the same thing for those students and those employees know where you're going to find your cancellations and your delays. But once that storm arrives, here are the things that we would really like you to do. Stay put. The fewer vehicles on the road means that roads are going to get cleared faster. It puts you out of harm's way. It puts other people out of harm's way. And those roads and those snowplows on the roads are going to have an easier time cleaning up. Can't stress this again, monitor your forecast. Always stay aware of what the changes are. Those changes are going to happen hourly, every 6 hours, every day when that storm is further out. And again, have a plan. Before that snowstorm arrives, before that snow falls, talk with your friends, talk with your family, talk with your employers to make sure what the actions are in case hazardous weather might impact you. But if you absolutely must go out into winter weather, or it's a nuisance storm, say it's a winter weather advisory and you're going to work, it's only an inch or two of snow, we want you to use something called common sense. We want you to drive to the conditions. Now, we haven't had snow this fall season, and a lot of times those first snowstorms or those first light snows are the most impactful. Slow down, maintain plenty of space between you and the car in front of you. Turn your headlights on. A lot of newer vehicles nowadays have auto headlights. That means during the daytime, if it's snowing, they may turn off. So you may have to learn or know how to manually turn your headlights on in those cases. And there's a lot of cases sometimes where you have auto headlights, they may not turn on those rear lights to your vehicle. Reduce your distractions. Don't be using your cell phone when you're in your car. Keep your noise or your radio maybe a little bit softer at times. And again, if you can't see, it's okay to pull far off to the side of the road or find an area where you can wait for the visibility to improve slightly. The last thing, if you're making a longer distance travel when winter weather threatens the region, always let somebody know the roads that you're traveling on, the time you're expected to be in that area, and the time you left. So in case something happens, people know where to look for you. So why is driving to conditions important? Well, you got to remember that stopping distance is going to change as the weather changes. Almost 10 times those stopping distances can increase by time you see snow or even ice. In the case of a dry road, a typically maintained car is going to be able to have 60 to 100 feet worth of space to be able to stop in time. Now, to put that in perspective, your football field is about 360 feet. Your average semi is about 70 feet. Once you start adding precipitation on those roads, all of that changes. A wet road, it might take you almost a semi and a half of distance in order to stop in time going at a 35 to 40 mile an hour pace. Once you add a little bit of snow, your reaction time even lessens further. It takes almost 180 feet or more to stop on a snow-packed road. Icy roads, boy, those are some of the worst conditions to drive on. 600 feet or more, almost 2 football fields in a glare ice-covered roadway. But as we said, it's those first snows and it's those minor snows that tend to produce the most problems. And why is that? We let our guard down. We get too confident in ourselves because, oh, it's only a half an inch or an inch or 2 inches of snowfall. Well, here's some data taken by the state of Iowa a few years ago. And that data surveyed resulted in the results that almost 75% of car crashes in Iowa happened with less than 2 inches of snowfall. 2 inches. So again, we want you to use your common sense. We don't want you to think you're invincible when it comes to driving in winter weather. So what do you do if your car gets stuck? Well, these can vary quite a bit by if you're stuck in a city or you're stuck out in a rural area, a rural side road. Obviously, we want you to have some way of communication with you. Call for help, indicate that you have distress. The hard part is depending on the winter situation and the winter storm, you don't know how quickly you're going to be able to be rescued. So we want you to conserve your phone battery in case you need to make multiple phone calls or multiple calls to let people know where you're at. Or they need to use such things as GPS to help ping your phone location. We want you to try to stay in your vehicle, especially if you're in a snowstorm and the visibility is very low. Use such things as coats or blankets to create a barrier to the outside conditions. All of our cars have windshields, and if you're not able to run your car, able to keep your car continually warm and the temperature is 0 degrees outside, the temperature in your car is going to get very cold very quickly. So that's why we recommend if you're stuck and you don't know how long you're going to be there, run your car every 10 minutes. Try to maintain both your vehicle heat inside your cabin, but also your engine heat. Try to, the one thing we'll say, like if your vehicle is running and there's deep snow that you're stuck in, you're going to want to make sure that your tailpipe or your exhaust is open so that if you're running your vehicle, that exhaust doesn't get pulled back up into the cabin of the vehicle. So how do you stay visible to rescuers? Well, occasionally, if you know traffic is coming, turn on your dome light, have some sort of light inside that you could signal for help with. Tie some sort of reflective clothing. Now you want to think about that winter survival kit that you might put in your car. Have some sort of visible, some sort of reflective gear that you could hang out your window and be seen when light passes you. If I'm stranded outside, this gets a little bit more tricky. You know, if you're inside or you're in a city and you get stuck, it's real easy to leave your car if you're in a safe spot and go to a nearby business and call for help or find somebody to help you. But if you're in a rural area or there's a lot of snow and you get your vehicle buried, it's going to be a lot more difficult. We want you to try to find shelter if you're able to, and if the conditions allow you to see where you're going and you know exactly where you're headed. But if there's no shelter and you're stuck, say, in the woods or in a very, very rural area, stay in your car as long as you can. If your car is, not able to be stayed in any longer, it's okay to use that snow as an insulator. Try to find some sort of shelter, tree bank, tree shelter, brush shelter, anything that you could use to protect you from both wind and you're going to use that snow kind of as an insulator from both the cold and that wind blowing at you. If you're in an area where you're able to build a fire, and this is, again, those very, very isolated and very rare situations, you're at camping, you're in a forest on a vacation and you're stuck, you can build a fire if you need to. Use warm rocks, put rocks around that fire to help warm the rocks, to help use those for heat, for your insulation that you might be wearing. The one thing we'll talk about, no matter what you're doing, if you're stuck in a situation, try to avoid eating snow as much as possible for hydration. If you're able to melt it safely, try to do that. But just know that the more snow you eat, and it can actually reduce your body temperature and push you a little bit closer to meeting that hypothermia threshold. If you're inside when the power goes out, well, what's the best thing you can do? If it's not safe to go outside, just stay inside. Try to conserve the heat in your house. Close off any unneeded rooms. Move everybody to, an interior room that may be kind of separated off from the windows of your house. Close off those rooms so that you can kind of contain all of your heat and kind of redevelop the heat in your room by having multiple people in those rooms. Eat and drink. Why do we say that? Well, eating and drinking keeps our metabolism up, keeps our energy levels up, which helps us produce more energy and more heat. Use those electronic devices sparingly. Again, you don't know how long the power is going to be out once it goes out. If you're in a rural area and it's a really bad snowstorm or ice storm, it could be days if you don't have any other power source available to power your home. Common sense would tell you it's really easy to add more layers of clothing when the power goes out in your house. One thing, don't forget about your pets. When the storm arrives, whether it's extremely cold outside when the storm has passed or whether the storm is actively moving through and you have high winds or a lot of snow accumulating, don't forget about your furry friends. Try to keep them warm and dry. Any outdoor pets, when extreme cold hits, bring them inside or at least allow them access to a warmer shelter. Give them plenty of food and water because just like us, they need to keep their energy resources and their metabolism up to be able to produce more body energy or body heat. And then when inside, if you're walking your dog and it's a short-haired dog, protect their paws, protect their skin if they have really short hair by bundling them up. Animals are just as susceptible to cold as most humans are. After the storm, what do we want to do? We want to monitor our road conditions. If you absolutely must travel, Check on 511 or safetravelusa.com to see the road conditions. And just be aware, if the winter storm is bad enough, it's going to take time for those roads to be cleaned. Give those plows plenty of space to be able to do their jobs. When it comes to cleaning around your house, cleaning that driveway, be very careful when it comes to those very wet, heavy snows. We see a lot of health related instances when it comes to people moving snowfall and running into some sort of health related issue while doing it. Wear good boots, gloves, and hats. Again, if it's really cold out and the wind's blowing, which a lot of times it does in this part of the country, it doesn't take long when that wind chill drops below 20 degrees, below zero, for frostbite to set in. Take frequent breaks. It's okay to go in. You don't have to do all that snow removal at once. And try to stay hydrated and try to stay warm and dry. Instead of using cold ice water when you go out, try to have something warm you can drink when you're taking those breaks. Be wary of cold exposure. We've already talked about uh, the sort of advisories and warnings temperatures we might see, but just know that frostbite is a real thing. You know, if you're outside for too long with with exposed things like such as your nose or your ears or your cheeks or fingers, and you start seeing them turn white, or maybe you get a little bit of a tingling sensation, or maybe even at times you lose feeling in your fingers, or your cheeks almost have no feeling to them, or your joints become really stiff. Know that might be the early signs of frostbite, and you need to take medical action. Remember, what are you going to do in these cases? If you see some of these things, some of these symptoms, head indoors to a warm room. You know, if it's minor frostbite or minor cold injuries, try to warm your extremities under layers of blankets. You know, if you use water, don't use hot water to rewarm your skin or rewarm your fingers. Try to use lukewarm or at least slightly warm to the touch water to do it slowly to prevent any damage to your fingers. Remove any wet clothing. Try to again dry off. Use warm blankets or warm towels to help you slowly warm back up. Hypothermia is probably the most dangerous type of cold weather exposure that we can see. What is hypothermia? Well, simply said, it's when your body temperature drops below 95 degrees. And this can happen many different ways. It can happen from cold exposure, both in the wintertime when you get trapped outside or you're outside too long. You start noticing things like confusion or uncontrollable shivering, or you're slurring your words or you can't get your words out. Maybe you unfortunately get to the point where you're extremely sleepy and you can't move your arms or your legs very well. Well, these are some of the signs that hypothermia is setting in and becoming advanced. Remember that hypothermia can happen at any time. It can happen at 0 degrees or it can happen in 40 degrees if a person is wet from rain, snow, cold, and you're stuck outside or trapped outside in rain and cold temperatures and cold wind, and you have no way of getting to any warmer shelter. Your body can start to lose core temperatures. If this is happening to you, what do? You're going to seek medical attention immediately. So let's talk a little bit about measuring snowstorm. The snowstorm or ice has moved through. How are we going to make sure we do this correctly? Well, snow measuring isn't so difficult in typical snowfall. It can be a much bigger challenge when we involve any sort of wind. So here's the basic 4 to 5 principles when it comes to snowfall measuring. We're going to try to find a flat, unsheltered area away from any buildings or high structures or trees or anything that may prevent snow from properly accumulating in those areas. We're going to give an example of some things you might want to avoid in a bit. Most of us has some sort of ruler or yardstick available. You don't need any sophisticated measuring devices. But one thing you're going to do, you're going to find that flat sheltered area and you're going to put what we call a snowboard out there. It might be a piece of plywood. It might be a hard surface that has a very light coloring. We like to use the color white. A lot of our snowboards are white because what does white do? It reflects all of the sun's energy or the energy that's radiated down towards the surface. Black surfaces like blacktop don't do that. They absorb more energy and they may actually increase their surface temperatures. You're going to use that ruler, you're going to put it on that stick parallel to or perpendicular to the ground, and you're going to take your snow measurement reading. We want you to try to get your eye level as close to that snow level as possible, because if you look at that uh, snow from above it, or you're looking down on top of that ruler measurement, you might actually underestimate your snowfall a little bit. In the cases of maybe you have some drifting in your area, we're going to want you to take multiple readings. We're going to want you to try to find at least 5 different areas to take readings and average those readings across to create your snowfall measurements. And then finally, you're going to report your measurement, which we're going to talk about how you're going to do that in just a bit. So where should I measure? Again, open area away from any obstructions, trees, buildings, anything that you might have out in your yard, fences. Why is this important? Well, what typically happens in winter? It's pretty rare to avoid any sort of wind when winter storms move through the area. And what happens to your house when wind and snow are falling? Well, that wind and snow may create something called drifting, or it may lead to a little bit more accumulation up next to various buildings. Underneath a tree, what's that tree going to do? It's going to shelter that snowfall from underneath the tree. In this example, we have a picnic table sitting right next to the tree. Well, that picnic table might be a good flat surface, but it's so close to that object that it's going to be influenced by that obstruction nearby. So what we recommend is try to find a spot where you can measure that's twice as far away as the height of the object that's nearby. So for example, you have a 25-foot tall home. You want to try to find an area that's at least 50 feet away from where your home is, or the same thing with a tree. So what snowfall measurement do we want to see? Well, here's a hypothetical example of what we might see during a snowstorm. So it's a Monday, it's 7 a.m., and snow is going to begin at around 9 a.m. in the morning. Now it snows very rapidly until snow ends at 1 p.m. in the afternoon. So you're going to take a measurement once that snow ends, and you're going to measure 2.4 inches of snow. Now, it hasn't snowed from 1 p.m. to 7 a.m. Tuesday the next morning. And if you're a CoCoRaHS observer, this is when you're going to send in your snowfall observation. Why is that? Why did that snow settle now to your observation of 1.2 inches at 7 a.m.? Well, snow is settling. The ground may be warm underneath it. The air temperature may be warming. There may be enough wind where it kind of compacts the snow. And so that snow settles down to that layer. So what we want to know is how much snow actually fell when the snow ended. And that's going to be that 2.4-inch snowfall measurement that you took once the snow ended. And this is what's important that you're going to report to us. So a few common frequently asked questions. Can I just measure from my deck or from my patio? Well, sometimes. In the case of extremely light winds, yes, this is possible. You might be able to do that. But in the case of any wind or extremely powdery snowfall, the problem is we're going to see a little bit of wind kind of enhance the snowfall areas on the deck and on the patio. So you may actually be measuring a little bit too much snow than what really fell. Can I measure on that grass? Well, a lot of people will just go out and stick their ruler or their yardstick out into the grass and get a measurement. Well, what's the problem with grass? You stick that ruler down all the way down to where it hits a hard surface, you're probably including about 1.5 inches to maybe 2 inches of grass in your measurement. So this is why we encourage solid hard surfaces to measure your snow on. Blacktop and concrete can sometimes be okay to measure. However, a lot of times they're going to lead to snowfall errors. That blacktop is absorbing heat. Early snowstorms can tend to lose a little bit of snow because the blacktop might be warmer from the warmer ground temperatures. So that first snowfall melts. Concrete can kind of serve the same purpose. It can kind of soak up and absorb some of the heat around it and actually lead to lower snowfall amounts. And do you measure in the same location? Well, it depends. Sometimes during winter storms, you might have a lot of wind where you get a lot of drifting. And that means you're going to search out for different reports. You're going to search out for different areas to try to find an average of those drifts. Measuring in snowfall, measuring in high winds and measuring in drifting situations is extremely difficult. You're going to want to use your best judgment. You may end up with some averaging totals in the end. But when you report that to us, we can kind of make those judgments and those estimations as far as what you're seeing and how accurate it is. Ice, pretty straightforward. Same as with snow, you're going to find a flat surface with any ice accumulations. You're going to use your ruler or your tape measure or yardstick, and you're going to measure it to that nearest tenth. You're going to repeat that on a few different surfaces and then take that average. Flat surfaces, it's pretty easy to measure ice, but on radial ice surfaces, it's a little bit more difficult. Now, a lot of our ice accumulation tends to take place on higher surfaces, such as tree branches or lines or signs. These are a little bit trickier. So in the case of a tree branch, what do we want you to do? Well, when freezing rain falls, it tends to do two things to a branch. You get a little bit of ice accumulation on the top of the branch, but most of the water doesn't completely freeze until it hits the bottom of the branch, or the water runs off of that surface and accumulates longer, stays on the bottom of that branch longer. So the ice accumulation on the top of the branch, in this case, is 1/4 of an inch. The ice accumulation on the bottom of the branch, or hanging off the branch, is 3/4 of an inch. So we want you to take those measurements, add them together, and then divide by 2. And that's going to give you your total ice accumulation that you're going to report to us. So how are some different ways you're going to report snowfall or ice to us? Well, the one valuable piece of information when it comes to winter storms that we need is what's happening at the current time. Well, there's a great app out there called MPing. MPing was created by the University of Oklahoma quite a few years ago. It's available on both Apple and Android phones. It can use your location to where you're reporting from and allow you to choose from various different things falling. In the case that the drop-down menu I'm showing here, for rain and snow menu, it can give you all the different things, whether it's freezing rain, drizzle, snow, ice pellets, mixed rain and snow, or mixed ice pellets and snow. These are just some of the examples of what you might see. The nice thing too, if you're afraid of sharing your personal information, it's all completely anonymous. What's going to happen is if you see things falling from the sky, you open your app, you submit a report for your location, send that in to us. We're going to see that on our computer screens, indicating what's falling under what we're seeing on the radar. The only caveat here is only for falling precipitation. You can't actually report how much accumulation you've seen. So a couple other things in order to report precipitation. We'd really love to gather more CoCoRaHS reporters. Now this is a volunteer precipitation network made up of all volunteer reporters. You have to go through a very simple online training, agree to send reports at a certain time of the day, but anybody across the United States can do this, or Canada can do this. Even on today's rainfall, the reports that we received here today were extremely valuable to us. The nice thing is they as well have an app where you can report your data directly. You don't have to always log in to a computer to do it. Once you've signed up for an account, you'll go through a process where you'll get assigned an ID, and then you'll be able to report to us. We have a few things through the National Weather Service that you can do. There is an online reporting tool that I'll show you an example of in a second. You can always email us. Our email here listed goes into our operations. Social media is our #1 tool for gathering information across our forecast area. Whether it's on Facebook or on X, we're always there gathering and looking for reports during ongoing falling precipitation or after the storm has moved through. And lastly, we do have a public phone number that you can call and relay those observations to us. Now, speaking of online reporting forms, here's the example I wanted to show you. If you head over to our webpage, weather.gov/Sioux Falls, and then look above the map. On the top left of the map, you're going to see a headline called Current Hazards. Clicking down this will open up a Submit a Storm Report option. Here's just a few examples of what you might see on this page. It's going to allow you to choose what you're seeing. In winter weather, it might be snowfall. In summer weather, it might be hail or wind damage. It's going to allow you to put the time it happened. It's going to allow you to put what your measurement was or what your observation was. And then it can use your device's location, or you can enter your address in to put where the location is, or where the report for the location is taking place. Lastly, if you want to, you can choose to put your name and your contact information into the report. Otherwise, you can keep it anonymous as well. Submitting that will again go directly into our computer systems here at the National Weather Service, and then we'll be able to judge just what is happening with the storm. So as we wrap up here today, I wanted to share with you a couple resources. These are some PDF forms that I've created here. You can get these forms at our webpage. We talked about this a little bit earlier, weather.gov/FSD/winter weather awareness 2024. Otherwise, they're also linked in our chat room here today. And after this seminar is done, you'll be getting an email in about a day that will also provide you with some of these resources. These are some very easy, quick reference guides when it comes to what typically happens in wintertime, whether that's various resources you might be looking for, whether that's knowing the terminology of a watch, advisory, or warning, or maybe that's the impacts of what may happen during or after the storm. It'll also give you some of those brief guidelines of what you're going to do to measure snow, measure ice, and then how and where to report. So I really encourage you after the talk today to go check out these resources, download them, and share them with anyone you might think could utilize them. That'll wrap up our talk for today. I really thank you for spending the hour and almost 20 minutes here today talking about the winter season ahead. Again, my name is Matthew Dukes. I'm a lead meteorologist. If you need to contact me after this talk or have any questions you'd like to have answered, my email address is linked here. I work closely in hand with Peter Rogers, who is our warning coordination meteorologist, our primary person who helps coordinate a lot of our services and outreach for our office. Feel free to contact either of us if you'd like more information after this class is done. You can always contact us by phone. We do have a couple different numbers here. Our public phone number is listed, but we also have an automated phone recording. 605-330-4444 will give you the forecast for our 4 major climate cities, Huron, Mitchell, Sioux Falls, and Sioux City, but it'll also give you, when the snow is falling, how much snow has fallen at the airport here in Sioux Falls. Find us on Facebook and on Twitter. We're always happy to communicate with you on those venues. I really hope this class has proven valuable for you here this winter season. I hope you've been able to take some of the resources you've learned and will apply them for the season ahead. With that, I'm going to wrap this up. Feel free to sign off as you wish. I'll leave this contact information up for about a few minutes if you need some help writing it down. Once again, Matthew Dukes here with the National Weather Service. I want to thank you again for viewing our talk today.